Hello, everyone. We are Team 14, and we're going to present our election challenge project. To begin with a brief introduction, our problem at hand is to make prediction on the 2022 US midterm election results using time series data. And our prediction include the seats in Senate and House acquired by the different parties, as well as the exact ballot counts of the election. Regarding the project's significance, from the perspective of the directly affiliated groups such as the candidates and their associated parties, it is important for them to utilize the election prediction result to guide their campaign strategies. And for the general public, these predictions are important for them to be aware and value their voting rights in affecting the election results. Our model is novel in that it is a summarized model that incorporates the predictions from 4 different machine learning models, and this will be elaborated in the following section.
So as Kelly mentioned, our task is to predict the state of the Senate and the House after the US 2022 midterm elections, as well as the ballot counts for each election. So for our data, we had 457 entries, and each entry, as you can see in the bottom table, is a compilation of polling data from that date. And then the data itself had 28 features, but we scaled it back down. We had a data frame like this for both the House and the Senate, and we used the mean seats and the chamber party values to predict the number of seats in the House and the Senate respectively, and we used the pot vote margin and the national turnout to predict the ballot counts. When breaking the data down, we used the data from the start of the polls, June 1st until the start of October as training data, and then the month of October as validation data to fine-tune each model's parameters. We then retrained the model on all the training data and predicted from November 6th to November 8th for the final election outcomes.
With the polling data as inputs, we devised 4 models, and the output from each of those models will be averaged. The output from the 4 models will be averaged to make our final prediction. The first 2 models are HMM models, which are classic time series prediction models. The first HMM model uses multiple transition matrices to represent the changing data, and the final prediction is given by the emission with highest probability calculated from those transition matrices. The second HMM model had a Gaussian mixture model to represent the emission probabilities. And then we also have a ARIMA model, which is a process that predicts future time series values by differencing a time series over order D to make it stationary. It then uses an autoregressive lag operator of order of P and a moving average with order Q to make a simple linear forecast. Optimal parameters were found via grid research. Lastly, we have the SVR, or the support vector regressor model, which uses supervised learning to predict the time series data with an emphasis on fitting the most data points onto the trend line. And then here's the results that we got. Overall, our models performed great with arrows below 10%. It might be due to the fact that we have 4 models. Each of them captures a certain aspect of the time series. And then by averaging the results from 4 models, we're reducing the arrows and biases, and which improves our overall accuracy.
Our predictions were off from the actual results because we based our predictions on poll data, which itself was not highly accurate, especially for House predictions. We could have improved by using additional data sets, for example, other polls and Twitter data set. In conclusion, poll prediction is still a challenging task due to its very dynamic nature, and it requires more research.